All right, we're gonna run through a couple problems you guys requested. These are all getting ready for the test tomorrow. So first up, I'm giving you the equation y equals negative 1/3 times the quantity x plus 6 squared plus 4. Describe the transformations in the following equation, then graph and give the domain and range. Okay, so right off the bat, I think about the actual vertex form, which is y equals a x minus h quantity squared plus k. All right, the a tells me whether I'm reflecting around the x-axis or not and whether I'm stretched or compressed. Looking at this problem, we are going to reflect around the x-axis because it is negative. Also, it's 1/3, so we are compressed by 1/3. Next, the h value. Now this tells me whether I move left or right. Now, because I'm adding 6, I'm going to the left 6. Lastly, the k value tells me up or down. I'm adding 4, so I'm going up 4. And that is all the transformation that you would need. Now, there's a lot of points there, and it's easy if you've studied and know by looking at it, up, down, left, right, stress, compressed, reflect, okay? Now, domain and range, we're going to do that right now. Domain, if it's a parabola, negative infinity, infinity. Nice and simple. Now the range. Now keep in mind, the range, I have to keep in mind two things. First off, I need to know that my vertex is negative 6, 4. And we're going to need that for graphing here in a little bit anyways. Secondly, if it is a 4 and it is a negative a value, it's opening down, which means negative 6, 4 is the maximum point, meaning it is at the top, so 4 is the maximum value, which means it'll be on the right side. If it opens downward, it's going towards negative infinity. And that's how I would quickly find the domain and range and the transformations for an equation. Now, as far as graphing, negative 6, 4, I'm going to go back 1, 2, 3, 4, 5, 6, and go up 4. Now this one may go off the graph a little bit, but that's okay. Now, table time. If you know, the AOS goes right down here. My first point is negative 6, 4. This might get a little tough to see, but from there, I'm going to just walk it out. I'm going to go negative 5, negative 4. I'm going to plug these two values in and see what we get. Now I plug a negative 5 in. Negative 5 plus 6, 1. 1 squared, 1. 1 times negative 1/3, negative 1/3, plus 4 gives me a 3 2/3. Now that's really close to 4, but that's okay. So I go back 5 and then up 3 2/3, mirror it. Negative 4. Negative 4 plus 6 is 2. 2 squared is 4. 4 times negative 1/3 is negative 4/3. Or easier, think negative 1 1/3. Add 4 to it, you get 2 2/3. So at negative 4, I'm up 2 2/3. And if I was mirroring it, it would be over here. It's a pretty nice curve. And there's how I would quickly graph it and go through transformations and domain and range. Okay? Next problem. Give the following information based off of the simple equation. Now, I'm going to come back to standard form. But vertex, you know just by looking. H, K. So my vertex is 5, 1. My axis of symmetry. X equals, very important, 5. How does it open? A is positive, it opens up. Now, let's see if we can get a little bit more of this. There we go, we see more. Now, if I'm going to find the y-intercept, there's two ways I can go about doing this. Anytime you want the y-intercept, make x 0. Anytime you want the x-intercept, make y 0. You could also get this into standard form and then just look at the c value. Those are your options. So let's go ahead and find this standard form right now. I need to multiply this out. I get 2 times x squared minus 10x plus 25 plus 1. Distributing the 2, I get a 2x squared minus 20x. Now I'm going to get 50, then I add 1 plus 51. And there's my standard form. Now looking at my standard form, I also now know my y-intercept, 0, 51. Now, let's take a look. X-intercept. Make y 0. Now you're solving. Okay, this is solving. You have options. Completing the square, quadratic formula. You can try and factor. Now what I'm going to do is I'm going to take a look at my original equation. I'm going to solve this way. I know that I have 0 equals 2 times the quantity x minus 5 squared plus 1. All right, I'm going to subtract the 1. I'm going to divide by 2. Now, at this step, because it's squared, I need to square root. Now, notice something. I'm about to square root a negative number. This tells me something already that I should already have known. There aren't going to be any real x-intercepts. Because, think about it, if I'm starting at 5, 1, 5, 1. My a value is positive, so I'm opening up. This will never cross the x-axis, meaning we won't have any real x-intercepts. Now we can finish this out just so we see the solving process, but understand you won't have any real x-intercepts on this one. Square root, we get I over the square root of 2 equals x minus 5, plus or minus. Now, at this step, we're going to have to actually start doing some radical properties. I can't have a radical in the bottom, so I have to multiply top and bottom by square root 2, which gives me plus or minus I square root 2 over 2. Last step, add 5. My x-intercepts, whoo, these were nasty. Don't worry, they won't be as nasty on the test, but it's good to be able to do something worse than the test when it comes time for the test. X equals 5 plus or minus I square root 2 over 2. Those would be my imaginary x-intercepts. Thank God they don't exist. Now, domain, you know it, negative infinity, infinity. Range, we already talked about this a little bit. 5, 1 is where I'm starting and it's opening up. So that will be a minimum, meaning the lowest I will get is 1, and it will go off to infinity and beyond. Okay? Graphing, I'm going to use that same concept. For my table, if my vertex is 5, 1, I'm just going to walk away from my actual vertex. Plug in 4 to the original. 4 minus 5, negative 1. Negative 1 squared, 1, times 2, 2, plus 1, 3. Plug 3 in. 3 minus 5, negative 2. Negative 2 squared, 4. 4 times 2, 8, plus 1, 9. So you'll see this will go off the graph pretty quickly. That's okay. At 4, we're at 3, mirrored point. At 3, we're way up here. So you know what? Estimate. Get our little Snoopy nose, and we're good. That's how I would gather all this information based off of just one vertex form. Okay? Next question. Now, quite a few of you asked for this one. Find the vertex form of a quadratic equation when given the vertex, negative 3, 2, and a point on a graph, 1, negative 5. Here's what I see when I read this problem. H and a k value, x and a y value. This is why this is so important. If the original formula is y equals a, x minus h quantity squared, plus k, I have 4 values I can plug in right now. Y is negative 5, x is 1. Now notice something here. We subtract the h, and if h is already a negative 3, this makes us a plus 3, plus 2. The only thing you have to solve for here is A. Once you have A, you can plug in your AHK and be done. Here we go. 1 plus 3, 4. 4 squared, 16. So negative 5 equals 16A plus 2. Subtract the 2. You get negative 7 equals 16A. So A equals negative 7 over 16. Now I have my H, K, and A. Time for the final answer. Y equals my A value, X minus H, which ends up being plus 3 quantity squared, plus the K value. Nice and easy. Plug in your HKXY, solve for A, plug in AH.